let's quickly provide a lasting solution to this interesting problem. We have secant x minus tangent x equal to 1 upon 4. We have to find cosine x. This is a very beautiful problem that is quite very simple. So solution, I'll write secant x minus tan x equal to 1 upon 4. I can actually solve this problem by squaring both sides, then cleaning up the algebra that we have, and then maybe using 1 or 2 trig identities. But I'm not going to do that. Because of the fact that we have secant x minus tangent x, I will try to look for secant x plus tan x, and I can do that by using the famous difference of two squares. So recall if we have a squared minus b squared, we are well aware that this becomes a plus b multiply a minus b. So in tackling this problem, I will say let a equal to secant x and b equal to tan x. Therefore, if I plug a equal to secant x and b equal to tangent x into the difference of two squares formula, I would then have sec square s minus tan square s. That becomes, then the first parenthesis, a plus b. So that will now be secant x plus tan x. The second parenthesis, we have a minus b. So that becomes secant s minus tan s. So you can see that the answer is calling already. And we already have secant s minus tan x, which is 1 upon 4. And again, from trig identities, we know that 1 plus tan square s is equal to sec square s. Okay, 1 plus tangent square x equal to secant square x. Then, in place of secant square x in this expression, I shall sub or infuse 1 plus tan square s. Then we are going to be having 1 plus tan square s minus tan square s equal to. Now, guys, secant s minus tangent x, that's 1 upon 4. I will then say secant s plus tan s, then multiply 1 upon 4. Now, tan square s we subtract out. Tan square s minus tan square s we subtract out. We are left with 1 on the left-hand side. Then on the right-hand side, we are going to be having secant x plus tangent x all upon 4. So if we cross multiply, we can then easily get the value of secant x plus tan x. So therefore, secant x plus tan x will now be 4. So I can decide to call this equation number 1. Now, from the very problem, we know that secant x minus tan x, that's equal to 1 upon 4. I'll call this equation 2. Then I will solve the two equations simultaneously. So we are going to add. If we add equations 1 to equation 2, secant x plus secant x, that will give us 2 secant x. Then here, tan square, okay, tan x, sorry for the flip. Tan x minus tan x, that's 0 to subtract out. Then on the right side, we are going to be having, okay, 4 plus 1 upon 4. 4 plus 1 upon 4, this is a simple fraction. If we use the multiply method, 4 multiply 4, that will give us 16. 1 multiply 1, that will give us 1. All upon 1 multiply 4, which is 4. So we'll be having 17 upon 4. So on the right side here, we are having 17 upon 4. The next thing we are going to do is to divide both sides by 2. So I can as well say let me multiply both sides by the multiplicative inverse of 2. So if I multiply a number by its multiplicative inverse, I will get 1. So 2 multiply 1 upon 2, that will give us 1. Then we now have secant x equal to 17 upon 4 multiply 1 upon 2. And this is going to give us 17 upon 8. Now we are looking for cosine x. We know that from inverse trigonometric ratios of functions, we know that secant x is 1 upon cosine x. That means that secant x is the inverse of cosine x. So it also implies that cosine x will then be the inverse of secant x. So now we already have secant x, which is 17 upon 8. So therefore, cosine x is going to be the inverse of 1 upon 17 all over 8. So if we take the inverse, that's going to give us 8 over 17. Now, if you are taking the inverse of a fraction, the fraction flips. So there's no need to write multiplication again. So we have cosine x equal to 1 upon 17 all over 8. If we take the inverse of a fraction, like I said, we flip. So then cosine x becomes 8 upon 17. So guys, if you enjoyed this video, please ensure you like and share with your friends and colleagues. And make sure you watch and subscribe to follow for more. See you next time and stay blessed.